All right, good afternoon, everyone. Welcome to the third session on BTC 2014. The session is on big data using Microsoft Azure. And today's speaker is Anoop. He's one of the MVPs in India. And he's going to take you through the big data concepts in Microsoft Azure. So let me hand over the session to Anoop to introduce himself and proceed with the session. Anoop, over to you.
Thank you, Biplab, and welcome to this session on big data using Microsoft Azure. In this session, we will go through some of the concepts related to big data. We will explore Hadoop as a platform, and we will see how to build applications on top of Hadoop and Azure. Myself, Anoop Madhusudanan, and this is a quick shameless advertisement plug here. So you can see my website at amazedsaint.com, and I'm in Twitter as well at amazedsaint. I work with Mar Labs as a practice lead for Microsoft and mobile applications. I'm also a Microsoft MVP in C#. So let us have a quick look at the agenda, what exactly we are going to discuss today. So we will be going through this flow. We will initially discuss what is big data. There is a lot of buzz about big data. We will try to see, what is the cream there and why everybody is talking about it. And the next point is, why should I care, or why should you care for that matter? Because, more than a buzzword, how exactly it is related to our lives and as a technology, what constitutes big data. And then we will go to Hadoop on Azure as a platform. From a technical implementation standpoint, we will discuss what is Hadoop and what is HDInsight for that matter. And we will see what is HDInsight. We will also discuss how you can actually create a Hadoop cluster in Azure for writing your own big data workflows. And in the end, we will explore how you can actually use your familiar frameworks and programming languages like C# to develop MapReduce applications that can perform data crunching in a big way. So that is the agenda for us today. So let us go to the details. So the first question is, what is big data? So there's a lot of buzz surrounding big data, and you will see that a lot of people are, making a lot of noises about this. So let us try to understand it from a different perspective. So when you talk about big data, all of you see that we are producing a lot of data each day, me, you, and everyone around us. So the big deal is the amount of data we produce every day is much higher in terms of volume, in terms of the size, and in terms of aspects like storage. So if you consider your live stream, you will see that data is coming to you every day from multiple social channels. You are watching videos, you are watching multiple images coming to you, you are getting notifications. And you also produce a lot of data. You may produce data from your wearables, from sensors that is attached to you, devices like Pebble and wearables that you may use. You may also use your smartphones for clicking images, for capturing videos and posting it to your social network. So each of us every day create a lot of data. And this data is actually categorized in multiple ways. You can see images, opinions, questions, answers, thoughts, ideas, advertisements, alerts, notifications. All these are different forms of data. So now you see that we are living in an ocean of data, and the streams of data is touching us each moment. And now the interesting aspect is you can crunch this data to leverage this data. You can crunch this data to generate insight out of that. For example, let us assume a scenario. Now Joe is a simple guy, and he's going to the college, and he's checking in saying, I just reached the college. and some of his friends, she views this in Facebook, and she might say, "Hey Joe, you are in the college, but you are not in the classroom. Where are you?" And then someone else comments on Joe's status saying, "I think he's hanging out in the cafeteria. I just saw him with Rita there." And Joe's mom is watching this entire information, and she is making an insight out of that. So she is understanding that Joe is not attending the classroom. He is in the college, but he is hanging out with some other girls, and she is making a prediction, right? And the prediction is, Joe's mark will fall this semester. So from the data streams, she's actually arriving at an insight or a prediction. And now this is possible in a larger way. If you have large volumes of data, you can take that entire data and crunch it and create a lot of insights out of that. Let us explore, a practical scenario here. So we are talking about large volumes of data, and I just mentioned that we are dealing with data in huge volumes. An example is the cellular data. Each of us are carrying a mobile phone, and we are moving around, and this information is captured by cellular companies. So as an example of how we can derive insights from data, I just want to bring up a story, actually an actual story that happened in Kenya. So this was reported in MIT that a researcher, her name is Beck. So she partnered with a lot of telecom companies in Africa, and she did a lot of research on how we can actually leverage huge volumes of data to derive insights out of that. That was for the medical domain. We will come back to that case study. But the key point is you can use data to derive insights. It could be for social and web analytics. It could be for fleet optimization based on traffic patterns, or it could be for advanced analytics for predicting future outcomes. So coming back to the example that I was mentioning, so what this lady did was, there was an epidemic spreading in one of the African nations, and she partnered with multiple telecom providers and gathered all the cellular data. So all the black balls that you see in the screen, you can imagine that those are like cellular towers. And all the spots, those are the people, in specific locations around those towers. So what she did is, she understood that an epidemic is spreading. And from all the spots where the epidemic is spreading, she collected this data. And she tried to correlate how exactly the people are moving each other. So she crunched the data and found that the movement patterns of people is actually influencing the epidemic spread. So she found that from a specific location, people are moving to nearby locations, and this causes the spread of epidemics. She traced the spread of tuberculosis back to a tea plantation in a specific location from this entire data. And that is pretty exciting because we are actually using large volumes of data and deriving insights out of that make the world a better place. And this is exactly what big data can do. Obviously, there are a lot of commercial applications, but along with that, big data also allows us to make the world a better place. So now the question is how, as developers, how we can actually leverage such technologies and how we can implement, this kind of workflows or data crunching methodologies in our own applications. So there are a lot of things that we can actually do with huge volumes of data. For example, you could partner with service providers to get cellular data and then use that data for identifying traffic patterns. Think about leveraging cellular data for solving the traffic problems in Bangalore. That will be a big service. Or you could build models to unearth patterns for solving issues like garbage disposal, traffic, etc., as I mentioned. So big data is not just about processing data. It's also about arriving to insights or providing recommendations. So there are multiple models that you can build on top of data once you have the data. This includes recommendation models, clustering models, classification models, and all these different models. So one of the commonly applied implementation is recommendations. A simple example is Amazon recommendation. Based on the user past user behavior, you could predict what's actually his preference for the future. In this example, you will see that how we could use user taste matching for predicting aspects like the preferred locations a user might travel to. For example, let's say user U1 and U2 and U3 goes to location L3 after visiting L1 and L2, right? So now, if the user U3 goes to L1 and L2, there's a good probability that he will also go to L3 because you will see that all the other users already did that, right? And based on that, you can arrive at a conclusion. If this user is similar to this user, then the probability is he might, follow the same pattern, and that is exactly, what taste matching is. Once you, find a cluster of similar users, then you could make stronger predictions, saying, based on the past behavior, this is the specific user is going to do in future. And to relate this to a practical example, you could consider, an e-commerce application which predicts or recommends products to a user based on his shopping history. So now let's come back to the developer question, right? How exactly we can build applications like this? How we will leverage common big data platforms like Hadoop and integrate that with the Microsoft stack, or integrate that with our .NET applications. And that is where Hadoop and Azure is coming into the picture. Hadoop and Azure is a platform that enables you to write and build big data workflows and integrate that with your existing Microsoft technology stack. So let us start with this question: what is Hadoop? Hadoop is a very common platform for distributed computing. And Hadoop provides a very robust, reliable, and scalable distributed computation framework, which allows you to implement programming models like MapReduce. So if you look at the Hadoop stack, you will see that the core Hadoop consists of HDFS, which is a distributed file system from Hadoop. It also has a MapReduce programming model. A MapReduce programming model is very interesting because it allows you to distribute a specific problem. For example, let us assume that you want to count from 1 to 10. A way of saying it is taking your entire numbers to count and then splitting it into multiple groups and giving it to your friends. And once they count them or add them, you can take the results back and sum it up again. So it's all about distributing a specific set of tasks and distributing them to the related nodes and then grouping them using a function like summation. So that is what MapReduce is all about. So Hadoop provides a robust MapReduce framework, and the latest version of Hadoop implements Yarn, which is again a framework for building MapReduce applications. Hadoop provides support for multiple NoSQL databases like HBase and Cassandra. So the NoSQL structure of these databases allow you to dump information into that. Now, for you to access this information, either you can access that as raw information, or it is pretty possible to build queryable models on top of this information. And that is possible using platforms like Hive or Pig Latin. So Hive provides you an SQL-like approach for you to execute MapReduce tasks on top of unstructured data. So there is a SQL-like language for Hive, which is known as HiveQL. So you can write a Hive query, and Hadoop will translate that to MapReduce tasks under the scene, and does the processing, take the data back and give it back to you. So then for you to import and export data from and to Hadoop, you can use Scoop. Scoop is a connector which allows you to connect to your RDBMS and pull in data and then export it back. You may also need to build intelligent models like the prediction models that we discussed earlier. You can either write your own distributed MapReduce logic, or you could use a standard framework like Apache Mahout for building your recommendation models or clustering models. Mahout provides you a very rich set of recommenders, classifiers, and clustering classes, which you can use out of the box, and you can integrate that to your Hadoop jobs. So now I already briefed a bit about MapReduce model, and you will see that it works in a distributed fashion. You submit a task to a resource manager, and the resource manager will take that specific task and split it down to different nodes. And each node will get a copy of data which is relevant to the task that it is executing, and the execution happens, and the result is actually fed back to the header node, and you get the results back. So we will go through an example later. But for you to develop applications, the first step is to have a Hadoop cluster. To build a Hadoop cluster from scratch, it takes you a lot of time, and that is where Hadoop and Azure is a very interesting choice. You can just go there and provision your Hadoop cluster in a few minutes. The next step is to load your data. So you can remote log in to the head node, for example, and dump your entire data into HDFS. So the HDFS or the Hadoop file system is pretty smart, and it knows how to distribute data based on the task allocation. So if a task is allocated to a specific node, HDFS will ensure that the data pertaining to that task is available near the node, so that the node can actually go to HDFS and fetch the data and perform the task. It also provides fault tolerance. So once you load the data into HDFS, then the next step could be to create and submit your job. There are multiple ways for you to create jobs, and one way is to write your own MapReduce jobs, as I just briefed. Another way is to write Hive queries, which translates that to MapReduce jobs. Another option is to use a platform like Pig and write your jobs in the Pig specific format. And all these high-level jobs are normally translated to an underlying MapReduce model, gets executed, and the results will be pumped back to HDFS, which again you can query using Hive or techniques like that. So let us now explore a bit in detail what exactly is HDInsight. So HDInsight obviously is a very interesting name for Hadoop on Azure. For you to start developing applications on top of HDInsight, you can either use an HDInsight emulator, which you can install in your local server machine, or you can go to Azure and provision your own HDInsight cluster and submit your jobs directly against the cloud. But it is recommended that you build your model locally and then go to Azure and deploy it across all the different nodes. So the main components of HDInsight, it consists of Hadoop core infrastructure, HDFS itself, Pig and Hive, and Scoop for exporting and importing, and Microsoft also developed an ODBC connector for Hive, which means you can actually use a tool like Excel or even from your programming languages to connect directly to Hive and query data using ODBC. So what happens is your request will be translated from Hive query language to MapReduce jobs under the hood, and it will be executed, and it will get you the results back. So there is a .NET SDK available to write MapReduce jobs. The .NET SDK also provides you classes for provisioning a cluster, an entire Hadoop cluster in a programmatic way. So you can actually write a job that provisions a Hadoop cluster for you completely using the .NET ecosystem, either in C# or VB.NET or even F#. Also, there is link to Hive available. It provides you a very easy access to query Hive from link. And what really happens behind the scenes is your link query gets translated to the Hive query language, and then that gets translated to the MapReduce jobs, and it gets executed on top of Hadoop. So this diagram, to some extent, explains how exactly HDInsight is integrated with other Microsoft platforms and technologies. As I mentioned, the .NET SDK allows you to write applications in C# and F#, and the JavaScript framework is also available, which allows you to submit your jobs. HDInsight also consists of other components like Pegasus and Hadoop. You can also configure Mahout. Obviously, the HDFS file system is there, and on top of that, the MapReduce framework is there. The latest version of HDInsight actually implements Yarn, which is the new way of doing MapReduce in the latest version of Hadoop. You will see that there are other data integration technologies available. HDInsight provides you a REST API for you to submit MapReduce jobs, and you can either use Scoop or ODBC as well for exporting and importing data. The distributed storage infrastructure is actually laid on top of Microsoft Azure storage, and you can actually configure an Azure blob storage when you create a Hadoop cluster. You can also import data from Azure Data Marketplace to HDFS for further analysis and translations. So let us go to the next section, which is very interesting. Let us explore how you can actually write MapReduce jobs in C#. So in this exercise, we will create a simple MapReduce job in C# for counting words. And for the sake of interest, we will write a simple MapReduce job which will allow you to count namespaces in your source code. So what we are going to do is, you can take your entire source code and obviously your C# or VB.NET code files. In this example, we will count the using implementation of namespaces, right? And we will find out what are the common namespaces that you use or that is used in your company's code base. So to start with, before we even begin, we need to go and provision a cluster. So if you go to Azure Management Portal, you will find that under HDInsight, you can actually create a cluster very easily. It's as simple as giving the cluster name and then providing the cluster size. An alternate way is to install HDInsight Simulator and do it locally. So once you have the cluster, the second step is, or the next step is to dump your data. So what we are going to do is, in this example, we are creating a new folder in HDFS. So the Hadoop fs command is actually for doing operations on top of HDFS. So what we are doing is, after remote logging into the header node of the cluster, the first step is to create a directory, input/code files, and the second step is to copy all your source code from a local folder to the HDFS folder. So you will see that the copy from local command line switch is used for copying your C# files from your basics revisited folder to the newly created input/code files folder. So the step 2 is obviously, doing the programming stuff. So you can create a console project in Visual Studio, and you can use NuGet command line for installing the MapReduce NuGet package, install package Microsoft Hadoop MapReduce, which will install all the required libraries for you to create your own MapReduce jobs. So the first step is to create the mapper. So the job of the mapper is to go through all the files we dumped into the HDFS and to go through each of the line and then basically parse it. And if at all we are finding a line that matches a using namespace pattern, we just extract that using regex, and then we just count how many matches are there. So that's what we are doing. So you see that we are extracting the line that actually follows the using pattern, and then we just dump that to the context. So context.emit key value basically outputs that to the next level when we do the MapReduce operation. So here, one interesting point to note is we are leveraging something called as Hadoop streaming. So Hadoop streaming is a way of doing MapReduce jobs in Hadoop using non-native languages. So that allows you to write MapReduce jobs using languages like C#. So once we have the mapper, the job of reducer is just to count the similar values. In this case, we are actually using a count function to count all the similar values. So once the mapper dumps all the namespace using namespace pattern lines, the next step is we count all the similar lines. So if you have multiple lines mentioning using system.io, we will count all those things and arrive at a conclusion saying using system.io is actually appearing 2 times or 3 times based on the number of usages. So we have the mapper and reducer. Now we need a job, and that is why we are using Hadoop job generic class, and we are using the namespace mapper and namespace reducer classes there as the generic parameters, and you will see that we are also specifying the configuration. So in the configuration, we are creating a new Hadoop job configuration, and we are specifying that the input path of that is the code files that we dumped to the input folder in HDFS. We are also specifying that the output should go to the output folder in HDFS. And that's it. And we are now ready to run the job. So you can connect to the Hadoop infrastructure, and you can actually execute the job. So when you execute the job, you just need to provide the type of the job that you're executing. And we are providing the type of the job that we created in the previous step. So once you execute the job, the entire process will kickstart, and you will see that we are actually leveraging Hadoop streaming there. So the MapReduce actions will take place. So how this works is, assume that you have your entire code files in the inputs folder. Now, the Hadoop infrastructure will split the files line by line and give this data to each of the node in the cluster. And it also executes your mapper job for splitting this, so that the mapper job is actually running on top of each of this line, and then emitting the values whenever it finds a using namespace pattern. And the reducer's job is basically to count this and give the results back. So you will see that how exactly the mapper and reducer process are working together, and the reducer is actually starting once you have the mapper reaches a specific threshold value, that is 60%, right? So once the MapReduce job is completed, we will find the output in the output/code files folder. So Hadoop will create the files by leveraging the name convention part 0000, part 0001 in that manner. So if you just view the contents of the output file, you will see that the namespaces are extracted, and the reducer is actually, combining the results, so that we are actually counting how many times a specific namespace is appearing there. So this is pretty interesting. This is basically a simple word count kind of implementation that we have done. So the mapper is actually, emitting the words whenever it is matching a specific pattern, and the reducer is counting how much times a specific, word is occurring, or a specific set of words in this case is occurring based on the logic that we wrote. And think about the scenario where you have to do this on huge volumes, and that is when Hadoop really makes sense. You can check my blog where I dumped the entire Stack Overflow data into HDFS, and I counted the number of namespaces occurring in the Stack Overflow data. And that is pretty interesting statistics, because that gives you insights, what are the questions people are asking, from what namespaces people are asking the most difficult questions, right? So you come to know, the popularity of namespaces, what namespaces are more difficult, what namespaces are, mostly used, insights like that. So now you have your entire data in this part file. If you want, you can go ahead and launch and load this into a specific table. So now what we are doing here is we are loading data from HDFS, and we are creating a table structure on top of that. The data still resides in HDFS, but when you do this stuff, when you create a table, it creates some metadata, and this is created at the level of Hive, right? So that we can actually now query this data in HDFS in a tabular structure. So this provides some structure for the data that you already have, and this is happening at the level of Hive. So you see that we are actually starting the Hive command line there, and inside Hive we are creating a new table and loading our file data into the table. So now the advantage is you can query this data, whatever data that we created, you can query this data using Hive QL, Hive query language. So that's all about creating your own MapReduce workflows in Hadoop and Azure. So to recap, we created a cluster. We loaded data into the cluster. We wrote a mapper. We wrote a reducer, and we also created a job that allows you to combine your mappers and reducers. And then we submitted the job to the Hadoop infrastructure, which kickstarted the workflow, which counted all the namespaces in the files that we dumped into the Hadoop infrastructure. Then we took the data back and put that into Hive. We provide some structure for that data so that you can actually query later using Hive query language. So if you need to understand more about it, I suggest you should visit my website and check out the big data articles. I have a couple of articles there that explains how you can actually write MapReduce jobs in C# and how you can use Hive query language, how you can use Link for querying Hive, and even how you can build your own recommendation engines on top of Hadoop and Azure. So to summarize, we discussed what exactly is the concept of big data. We also went through the process of creating a big data workflow, assuming that we have a lot of data. So this was a very simple scenario where we counted the namespaces in a large set of source code files. But but the underlying fact is you can take this principle and build your own MapReduce models for doing ridiculously big tasks on top of very big data sets. We haven't really discussed in detail how to build recommendation models and everything, but as I mentioned, if you're interested in that, you could definitely check my website and see how to do that and even experiment that on top of Hadoop on Azure. Azure really made a lot of change, really made a big difference in terms of bringing together big data, cloud, and mobility, and that is a really big opportunity. If you really look at Azure mobile services, there is a big possibility out there. You can actually use mobile services for pumping information back from sensors and mobile devices back to the cloud infrastructure, and then you can write your own big data workflows on top of Hadoop on Azure for processing these large volumes of data. And that is a very exciting opportunity when I look at that. With that, I conclude my session, and thank you very much for attending the session and going through this. I really suggest you take an account in Microsoft Azure and check out the Hadoop infrastructure available and start experimenting with creating some of these workflows and see how you can use that for bringing value into your business. Thank you very much. If you have any questions, you could put that in the QA window, and based on the priorities, I will try to answer.
And there are some questions, I believe, Anoop, if you want to address them.
Okay, so the question is, a small briefing on HDFS would help all. So the way HDFS is structured is you basically have a fault tolerant set of nodes clustered together. So the way the data is distributed is actually based on some algorithms. And one thing that HDFS ensures is the node that is processing a specific task will be having related data that is required for performing that task. So I think an entire briefing of the HDFS architecture itself is outside this. But if you look at the latest Hadoop infrastructure, the MapReduce implementation itself is actually revamped in a big way. So if you look at Yarn provides you a resource manager at the head node, and the resource manager is actually responsible for taking the data and splitting it to the nodes. And from the nodes perspective, the coordination happens and the reporting happens. So Hadoop always ensures that the data that you need for performing a specific task is available to the node at the time it performs that task. So whenever it actually replicates data in HDFS level, always the data is replicated as well, which means a node, whenever it requests data, a replica of that data is also available in the nearby nodes. So even if one of the nodes fails, Hadoop still ensures that data copy is available for the task to perform.
All right. And if there are any other questions from any of the attendees, they can just post it. All right. I think there are no other questions. Well, thanks a lot, Anoop, for the wonderful session, and I'm sure it was very informative to all our attendees. And just an update for the attendees that there would be an automated survey coming up to you from the events team, and we request all of you to participate in that survey and give us feedback in terms of the topic, the overall logistics, and also the speaker and content. So if you have any feedback, any suggestions, do let us know through the survey. That would help us in planning the future sessions. And also don't forget that there are other sessions going on VTC. Sessions which are there on developer track. From now, there are a few app-specific sessions. Windows Phone app, which is a multilingual Windows Phone app. There is a Windows Phone and Windows app session, and also the app-to-app communication in Windows Phone. And if you are an IT Pro person, you have a SQL Server session, you have a SharePoint session, and you have an Exchange session. So that's the plan for the rest of the day in BTC. And once again, thanks a lot for joining the session, and we look forward to seeing you in the other sessions. Have a nice day ahead. Thanks, Anoop.
Thank you, Biplab. Yep, thanks.